This is section 6.4 on logarithmic functions, and now we're on example 8. And we're going to solve exponential equations with a base e or base 10. We've done some, but we're going to do some more now. We've done some because we've had to change our log functions into exponentials, and we solved those. Okay, step 1 says to isolate the exponential part, and now we're going to change it to a log and use either the log key if it's log base 10 or the ln key if it's log base e to evaluate the variable. So this time we're asked for an exact form and a 3 decimal approximation. So we will be calculating that irrational result in rounding. Okay, so notice now the variable is in the power, in the exponent. In the log functions it was in the argument. So now it is in the exponent, and so in order to solve for this, we'll want to change it to a log, because what happens when I change it to a log? Remember, let's just make a note here. Y equals the log to the base a of x if and only if, it's my little abbreviation for that, a to the y equals x. So notice that we have e to the x equals 7, a to the y equals x. When you isolate and change it to a log, what happens to the exponent? It's now over here by itself. So notice that's what's going to happen, and we'll be able to solve for x. So to change this to a log, we'll say the exponent equals the log to the base e of 7. Right? So log base e is written like this, ln. That's what that is, ln. And that's a number. Natural log of 7 is a number. In exact form, we'd write it's the natural log of 7. Then on your calculator, you would calculate the natural log of 7, rounding to 3 decimals, and you would get 1.946. Be sure you can do that. Check that as you work through these with me. You should be using your calculator, see if you're getting the same thing. Okay. This one said isolate the exponential part. It was already done. But look at B. The exponential part is e to the 3x. It has not been isolated here. So the first thing we're going to do is isolate the exponential part. Now, e to the 3x equals 3. Now we have the exponential part all by itself. We have an a to the y equals x. We can't have a 3 times a or 2 times a to the y equals x. It has to look like this, and now it does. So now 3x, that's our y part, the exponent y equals the log to the base a, well our base is e, so I'm going to write ln, of 3. Right? So y equals the log to the base e of x. Okay, I'm solving for x, so I've got to divide both sides by 3. So the natural log of 3 divided by 3. That's the exact answer. No rounding involved. Now I can take the natural log of 3, divide that by 3, and I get 0.366 rounded to 3 decimal places. Example C, the exponent is already isolated. So let's change it to a log. The exponent, 5x minus 1, equals the log to base e, I'll write as ln, of 9. Add 1 to both sides. And I like to put the 1 in front here. I don't want it to look like it's the natural log of 9 plus 1 and then think I'm writing the natural log of 10. That's not the case. It's the natural log of 9 plus 1, right? So I added 1 to both sides, and I'm going to put it in front just to make it really clear what I'm doing here. And then I'll divide both sides by 5. So x equals 1 plus the natural log of 9 divided by 5. So that's my exact answer. Now I'll calculate that and round to 3 decimal points, and I get 0.639. Okay, so recall again what I did here. The reason I could have written natural log of 9 plus 1, and that's fine as long as I don't get confused and think I'm supposed to add the 9 and the 1. This is a number, the natural log of 9, okay? And so it's different than the number of natural log of 10. So 1 plus the natural log of 9 is not the same thing as the natural log of 10. Be very careful about that. Okay, I've got a couple more here in example 8. Remember, we start by isolating the exponential part. It is not isolated right now. Here it is in the parentheses, but it's being multiplied by 4 and having 1 added to it. So let's start by subtracting 1 and dividing by 4. So we have 10 to the 2x equals 5. Now we'll change it to a log. The exponent y equals log, what base? 10, so I don't write anything, right? If log with no subscript is base 10 of 5. So divide both sides by 2 to get x equals the log base 10 of 5 over 2. So there's your exact answer. Log base 10 of 5 over 2. And then if you calculate that, I think it was 0.349 is the 3 decimal approximation. Log base 10 of 5 divided by 2. Okay, and our last one in this part, example 8, is 3 times e to the 2x plus 1 minus 2 equals 10. Okay, again, we have to isolate the exponential part. 3 times e to the 2x plus 1 equals 12. I've added 2 to both sides. Now let's divide by 3. E to the 2x plus 1 equals 4. Now we'll change it to a log. The exponent, the y part, y equals log base e, ln of 4. Subtract 1. Again, I don't want to make it confusing and make it look like the natural log of 3, 4 minus 1, so I'm going to put that in front. So you should calculate that. If you think the natural log of 4 minus 1 or natural log of 3 is the same as this, you need to check it because they are not the same. So it does matter how you write it because you might get confused. Divide by 2. Okay, so exact answer is -1 plus the natural log of 4 divided by 2. And when you calculate that, you should get 0.193. Okay, example 9 is just a calculator exercise. You're to take the natural log of 11 plus the natural log of 23 divided by the common log of 11, log base 10, plus the common log of 23. I'm just going to put the answer here. I got 2.30258 and so on, which I rounded to 3 decimal places as 2.303. You should be able to do that. If the only way you can do it is to get 4 different values and then add and then divide, that's fine. It just depends on your calculator. We're not using graphing calculators, so most of the calculators you have, you will have to do it in stages. But just remember, you're using natural log for the 2 in the top, calculations in the top, and common log for the 2 in the bottom.